Okay, guys, today I'm gonna talk about singly linked lists. I'm gonna start this. Let's start this free material. So this is basically what is a single linked list. Where is my scrolling around? The classical representations. Node. That is linked to another node. Okay. This guy here is the pointer. This guy is pointing to this guy here. The last element point to a null guy. Okay, this is the head. I think this is the tail. I don't know if this is the tail. It seems to be the last one, I guess. Check here. It's not have data. And we have the pointer, I guess. Next, I believe next is the pointer. Let's see if it's some reference to this. books because books are I believe that books still has a good value because they believe more in the information than internet. Internet has good content, but when I am a student, I like to use books. I think I'm old school. So, okay, this is the guy. Private class, node, item, and next. Let me check here. So, linked list is a recursive data structure that is either empty or a reference to a node, having a generic item and a reference to linked list. So this is more a reference than a pointer. So I guess let's put a reference here. So the node is an abstract entity that holds the data and a node reference. So this guy. This is abstracting of what a node is. I'm still not there. So these are the instances that we call it. Here in the book he called item. Here is calling data. Very similar, but I am familiar with item, so I prefer item than data. The item and the node. Okay. Here are some programming idea. Make private because it's not for the node will not the node should be used by the client. Okay, if you want to access the item, the data, this guy should not be accessible outside the class. This kind of information is interesting. As with data type, we create an object. Okay. I will be skipping this. Maybe I can come back later. I was just using this to share better the names that you are looking at. I was confused about this. Let me go to these names. First item, second. Okay, maybe I will come back later here. He also called next, but it's a reference. Okay, let's continue here. any type of object, so linked list can handle different type of objects. Here we have characters, objects, types. The next component is a pointer, so I was right. So what we call reference, it can be what I call it pointer. Reference is a pointer. The start of the linked list is the head, okay? Head is a pointer. That point is to the beginning of the linked list. So if you want to traverse the linked list to obtain or access an element, we will start from head and move on. Okay, so this guy seems to be something more like this, because the head pointer to the node. You can see that it's different from this representation here, and maybe the tail, it's what I'm calling tail here is something like this. I don't know. The last component that is where I'm now. Let's see here is notion of the last node points to a new object, and that tells you that is the end of the list. So there is no tail here. So this guy points to this no idea. So this is no. It's no. Okay. So here we have a representation about the race against linked list. So, okay. Insertion, deletion at the beginning of the array or the linked list given a value. So it's all fun. And linked list is time complexity 1. I understand why this guy is 1, because you can, I believe we can. Quite simple. If I want to put something in the beginning, I can remove this guy. It's not removing, it's more about pointing to a new node. Another color here, and this reference can change. It previously was this guy, but now it comes from here. So I believe this is why we can think about time complexity of big O of 1, and this guy needs to be linked to the node. How can I insert something here? I believe the best way should be, for example, creating another list or array, putting the new guy here, new element here. Something like this. For example, let's suppose that four. I believe the best way is to insert an element or an item in the beginning of the array. Should be we can use another memory space in place. For example, the new element is 5, and then we can move this guy to this place, this guy is to this place, this guy to this place, and this guy to this place. 1, 2, 3, 4. Let me check here. Let me ask ChatGPT. Let's ask ChatGPT what he thinks about this. Okay. So insert and delete at the beginning of the array is O of n. Is it right? Create a simple explanation. Okay, let me see if GPT returns something interesting. I like to use another tools like Grok, and I also use Perplexity, not Perplex for this, Perplexity more for research, and Gemini. I basically use these three tools. Let me check each one. The first one is Grok. What's Grok returns? No, insert and delete at the beginning of array is not OFN. Oh. It's telling me that it's not. So he's telling me that it's not, but it's telling me that I need to shift all the elements. Basically, it was what I did, and so we have a contradiction here. This operation has a time complexity of O of n. Okay. He is telling me that it's not, but he is based on the explanation. I think it is. Okay, again, this operation take of n. So insertion at the beginning of array is indeed OFN. No. So I believe this is what I was thinking. That is OFN. We need to shift the data, but you can see here that this guy has this contradiction here. Let's see what GPT. Yes, it's correct. It's typical OFN. Let's see. Array structures. So array stores element in contiguous memory location. Okay. So it can be accessed directed. Okay. Let's see about insertion. When you insert an element at the beginning, you need to make a room for this new element. So okay. Every element must be shifted one position to the right to be free. So I was right. So this guy is one. These guys what? It's the guys that were shifted. I don't like this letter. I like this one here. Some people don't like, but I like it. So okay. Hooray. Here you go. Curve. If there are n elements, you need to shift all of them. Okay. When you delete, and he give you more information than I ask, no problem. When you delete an element from the beginning, a gap is created to maintain a gap. Every element after delete need to be shifted to the left. Okay, it makes sense. So similar, it's OFN. It makes sense. Okay. It's like if I want to put something at the beginning, I shift everything to the right. If I want to remove, I shift everything to the left. I think this information is fair and it's correct. So I'm gonna stay with them. I'm not gonna use books to a book. No, here in this case, I believe this is correct. Face random access. So in the scenario, you need to shift all the elements. Okay. Important to note. Let's check. Yes. Gemini returns more information. He's telling me that if I need to insert in the end of the array, there is no need to shift, just put the element at the end, so we have constant time. And okay, it makes sense. And there are alternatives there to the insertion, deletion. Okay. I like this. I like more the Gemini answer to this question, but Gypsy is okay. But Grok creates some contradiction here. Although it returns the right answer, it returns contradiction. Interesting. Let's come back here. So now we understand. Now I understand why this is OFN. So right, access the element. Okay. Array, it's about the access the index, so it's constant time. Okay. If I want to access the element one, I just point to that place in memory and get an access the element. But linked list, it's OFN. I don't remember why. Let's thinking about this. It seems that I cannot access by reference. I need to. I think what it's telling me is that I need to. If I want, for example, access this element here, I should be starting from the head. Go to the first element, the second one node, and the third node. I don't know why. I know that we don't have indexes. We have reference and pointers, so access an element, and simply link is direct. In a constant time. So let me check what this guy's return. Okay, Grok is telling me that I need to traverse the list to find the element. Okay, this is what I thought, but I don't know why we need to do this. Grok is telling me that we don't have, we only have the next reference. Okay, if I want this element here, I need this previous pointer, okay? And I don't have this previous pointer here. I believe it makes sense, so I don't know. I need the previous element to look for this guy. So if I want this and I don't have the information about the previous element, the reference, I don't know where it is. Okay, it makes sense. Here array are contiguous, so we know that these guys are at the same are placed in memory together, but linked lists don't work like this. So I believe it makes sense. Okay, let me check what Gemini is telling me. Okay, it's I believe that this is the problem. Singular linked lists don't store elements contiguous in memory, so this is a problem. So each element holds the data and the pointer to the next element. So if I want element 3, I can only know about the 4 because I don't have the previous pointer. So okay, and it come across for access. This is the cost. We need to traverse all the list to access the element. So for some case, this should be not the best behavior. No direct index, so like arrays where elements are stored specifically like this. Okay, you cannot jump directly to a specific link. Okay, you need to traverse. And let's see, GPD. The reference for the head, then we need to traverse. answer. Okay. Okay, it makes sense. I believe this is what I was thinking about. Singly linked list. And contiguous memory array, yes. Linked list, no. Okay. I believe this will be repeated information. We already know that inserting deletions time complex of OFN, so I'm gonna bypass this. Okay. Insert a node at the head, give a node constant time operation. Okay, an access element, okay, and contiguous memories. Arrays are contiguous in memory. Alright, read about this. There is a trade-off between arrays and linked lists. Okay, I believe I understand the trade-off. It's basic. If I need to access faster, better array. If I need to place in something at the beginning of the data structure, maybe linked list better. Single linked list. Now let's go ahead and create our classes in Python. Node class and linked list, it separates the structures. Interesting. Okay, it's like you can create a node and I can create a linked list, and I think this linked list will call the node. Okay, we create a class node. The constructor of this class we give an argument of something data. Every node is going to consist of data and next. Okay, so in this constructor he creates data and data and a pointer to the next element. Here in Python we are creating the attributes of the class that we can access from every place on the class, and it's creating the data and the pointer with the data itself, the item, and the next the node start pointing to a new representation, this guy. And in Python we use none. Okay, and linked list, the only thing that is different here, no, not the only thing, but what the property of the linked list seems to be just this. Okay. What is set next? Is thing. Now that we have defined a class in our implementation, we will learn how to insert elements into linked lists. Okay. So I'm gonna just create this guy here, these classes, to use in the next operation. For today I will be only studying this basic, this the fundamentals of the single English. I believe tomorrow or from next day I'm gonna be studying and implementing these operations. They are private, I cannot have access, so I need to do by myself and or researching the internet to learn how to do things. The only thing I'm gonna do here is I'm gonna create this. Okay. So I have in my GitHub repository some data structure, some content of this. So if you want to check, so it's public and you can easily download. I'm gonna create stack. I'm gonna create a new folder here. I'm gonna call single because it's what we are singly, not single. Singly linked lists. And here I'm gonna create my files. I'm gonna call this singly linked list file. We start with by notebook. It's easier to learn. So if we think in our problem, we can separate and create a node. So it's just the same thing. I just want to memorize this. I believe we have the class node. The class node should be initialized. When I instantiate, when I initialize its class, I need to pass the data, let us call it, and this data will populate the attributes of data, and we will start the pointer. I like to call pointer, but it seems to be a convention. Use next, so I'm gonna keep it. And in Python, we call this node. So this is the new end. And the linked list. It's not just a linked list, it's singly linked list. Okay. So the only thing we have here, it will be the head. I believe that next steps I'm going to understand this better. So I've got the head, and I believe the head is pointing to node 2. Just to check here. Okay, no, we don't have nothing. Okay, so for today, I will be only studying this. Bye bye, guys. See you next